Okay, so today we are going to look at another standard question that can be set in any standard exam. Without wasting time, the question is how much heat is given out when a piece of iron of mass 50 grams and specific heat capacity 460 joule per kilograms per Kelvin cools from a temperature of 85 degrees Celsius to 25 degrees Celsius, full stop. So we are expected to calculate heat given off, okay, or given out when a piece of iron of mass this range and specific capacity this cools off, okay? That means the iron must have been heated to a certain range. Now it's cooling out, okay? Or it's cooling off, something like that. All right, what we need to do first of all, we write a solution, okay? You observe something here. This question is not an objective question. This is a theory question, okay? Whereby you are expected to solve, show your content or your data. That is the content of the question. Data means the information that the question contains. And then you show your steps, show your formula, and so on and so forth. So it's not an objective question, so to say. Take notes. So in that case, what you are expected to do is outline your steps. Make sure your steps are very, very clear. The first thing, you write down your solution. This next thing to do, you bring out your data or parameter contained in the question, okay? So let's bring out our data, right? Data as contained in the question. The first one is how much heat? That means we're looking for heat. Can you see there? We're looking for heat. So heat, H, is completely unknown, all right? Is unknown because we don't know the value yet. So we're going to look for heat. And that makes things quite easy for us. Already we know what we're looking for. When a piece of iron mass, so we have M mass, okay, is equal to 50 grams. We can as well convert this to kilograms by saying 50 grams over 1,000, all right? And that gives us a 0.05 kilograms. It's been converted already, all right? So let's go. So what next? Specific heat capacity is given as 460 joule per kilograms per Kelvin. Specific heat capacity is represented by small letter C and is written as 460 joule, come on, per kilogram, right, per Kelvin. Good. And finally, what are we looking for? Difference in temperature. Cools from a temperature of 85 degrees Celsius to a temperature of 25 degrees Celsius. So this is theta 2 and this is theta 1 in initial temperature and final temperature, okay? So let's take it that way. Theta 1, initial temperature is 25. 25. What's wrong with this chalk? Come on. It's 25 degrees Celsius. Final temperature is 85 degrees Celsius. Okay. And what next? We need to state the formula we are going to use to solve this, all right? And the formula is quite simple. That is H, which is the heat we are looking for. We are looking for heat. H is unknown, okay? Is equal to M, C, and theta, okay? Where theta represents change in temperature, right? So we have our mass, the specific heat capacity, and temperature change. We can as well state this to be H equals to MC, bracket open, theta 2 minus theta 1, bracket close. So any of this can solve. So what do we do next? We substitute, okay? We substitute. So substitution has it this way. H is equal to MC theta of 2 minus theta 1 By substitution, mass is 0.05 times, all right? Specific heat capacity is 460, and that is 460. We may not consider the unit now, all right? And then difference in temperature. That's another area we need to look at. Very, very interesting. So let's look at this. I want to shift a bit so that mass is 0.05. Specific heat capacity is 460. And then there is difference in temperature, which we have 85, right? Minus 25, bracket close. So with this, we're making some progress. Okay, so let's continue. H once again is equal to 0.05 times 460 times. Difference here is simply 60, right? 85 minus 25 is simply 60 degrees Celsius. Okay, so that's it. We can as well move on with H. We can solve this even without using calculator. Okay, we can do this, change this to 5 all over 100, and then 460 over 1 times 60 all over 1. Good. Okay, this is just trying to normalize the simplification, okay? So with this, we have how many zeros here? We have 1, 2, we can cancel 1 0 here, all right? Cancel 1 0 here, and then come down here, cancel this and cancel that. So we are now left with what? H is equal to, what's the values remaining? 5, 46, and 6. Yes. So we have 5 at this point times 46. This is 46, 46. All right? And then finally we have 6. So what do? What I want you to do is use a calculator this time around, or you can do this simple mathematics. 5 times 46, after which times it by what? 6. Whatever it gives you, put it here in the comment section. Comment it in the comment box. Alright? So that's how to solve it. Very simple. Now, how the examiner, how he or she is going to mark this question is very simple. First of all, the person has marking scheme or mark scheme, so to say, or marking guide or mark guide, so to say. So the person, the examiner will check, or have you been able to identify? Have you been able to identify the letter you're looking for? That's heat. The quantity you're looking for is heat. He or she will check this and then score you. Check your data, accurate, and then finally check the formula which you have stated. Alright? Check the formula and score you. Score you here for your data, score your formula, and then substitution. Check your substitution or substitutions. Are they accurate? And then also score you. Then final answer scored. So that's how it is called when this marking exercise commences, okay? As soon as it commences, the examiner takes these steps in marking your scripts. So it is very, very important that you outline your steps one after the other. Make sure that you don't just cancel unnecessarily. If your writing is such that people find it difficult to read your writing, make sure your writing is legible enough so that anybody can read it at any point in time. I think that is it. I'm signing at this moment to prepare for next class.